And so this paper, it kind of describes the whole process. I put this paper on Classroom, so if you need some like nighttime reading and you want to go through this paper, but I'm going to describe it anyways. And so this whole process that we're getting into, it's using our natural logs, but the purpose is when you have a problem, like let's say, I'll make this really big, like this right here. So it's y equals x to the x power. All of the stuff that we've learned about deriving before, we can't use right here because here's the reason why. So with that, we can't use what we've learned before this. So we're going to put a natural log on each side. And I'll write this a little better underneath. Natural log of y equals natural log of x to the x power. As we can put it on, we can enter it into the problem as long as we enter it into both sides. And then yesterday, when we were reviewing pre-calc properties, if you have a power with a natural log, you're allowed to bring that power to the front. So then this is going to be the natural log of y equals x times the natural log of x. And then now we no longer have a variable in the power, so we can derive it. But we've made it implicit because of this side. So we have to derive left to right. So what would be our derivative of natural log of y? Do we remember from yesterday? There we go. 1 over y dy dx. And then we actually had this as a problem yesterday too. Do you remember what we had to do to derive x times the natural log of x? Product rule. So that's going to be first times the derivative of the second. So the derivative of the natural log of x is 1 over x plus the second times the derivative of the first. Okay, I'm going to clean up the right-hand side before I do anything else. So on that right-hand side, this part will give me just a 1 because it's technically x over x plus the natural log of x. Okay, then my goal is to get dy dx by itself. So the way I can do that is multiply each side by y. And then on the left-hand side, I'll have dy dx left. On the right-hand side, I'll have 1 plus the natural log of x. But I'm going to replace y with its original equation. Y was equal to x to the x power. Ta-da! That's all we have to do. Easy, but scary. Okay, so we have this process that we're just going to practice as much as we need to. Of course, there will be some little tricks along the way that we'll see. What would math be without that? But let me show you this, all of these problems. Yeah, we had some pretty big ones yesterday, like quotient rules and chain rules. Okay, so looking at this, there are some on here that we won't have to put a natural log in. Like we could have done it without that. So for example, number 5, couldn't we have done this like old-fashioned chain rule? Okay, what else could we do up there without putting a natural log in? 6, 8, and 9, we wouldn't need natural logs. 1, we will. 21, we wouldn't. 11, we wouldn't. We just would have to know the arc sign rule, which we haven't got to yet, but yeah, we wouldn't need to. Yeah, 16 and 16, 17, 18, we wouldn't. I think that might be it. So we're not going to focus on those today because we want to get to practice what we need to practice. But I've got the order that we'll go in. So I'm going to switch screens and I'll just write the problems up here that we're going to solve. So this one, the first one we're going to go for on this page, we're going to go with y equals x squared minus 3x plus 1 to the x power. Okay, now there's that variable in the power, which means we have to put a natural log in. So we'll put a natural log on both sides. And that means we can bump the x down to the front. So natural log of y equals x times the natural log of x squared minus 3x plus 1. Okay, then, since we don't have a variable in the power anymore, we are good to go to derive. So we just derive left to right. This side you'll just get used to. When we derive this side, it's just going to be 1 over y dy dx. On the right side, it's still a product rule. It's x times all of this. So we do first times the derivative of this. So we just learned this yesterday. I know it's still fresh, but you know how we made this like our u? That was our inside stuff. So we do 1 over u times the derivative of u. And I know we haven't known that very long. We got first times the derivative of the second plus second times the derivative of the first. All right, I'm going to simplify the right-hand side a little bit. And what I'm going to do for that, for this first term before the plus sign, I'm going to make it x times 2x minus 3 all over x squared minus 3x plus 1 plus the natural log of x squared minus 3x plus 1. And then, last thing we have to do, multiply each side by y. And so then dy dx. Once we get more comfortable with this, you're going to be able to skip more steps. You're going to feel more comfortable not writing as much. We'll have x times 2x minus 3 over x squared minus 3x plus 1 plus the natural log of x squared minus 3x plus 1. And then all of that, so put that all in a big parentheses, times y, so times our original equation. And there's our answer. It's pretty intense. Look at what you can do. What if you like showed your like yourself in August, like what you would be doing? All right, we're gonna try another one. Just practice makes perfect. But look what you can do. I know. Like you'd have to go in the whole like into the like whole derivative thing. Yeah. All right, let's try this one. Y equals 4x to the x power. Okay, we have to put the natural log in because of that x in the power. Do you want to try this one on your own for just a little bit? See how you do? Then we can check it. I know, I know. You like that won't just go away. I know. What's nice about these is they can look really messy and we don't have to like simplify them really. Yeah. Even like, so I know you guys don't take the AP test, but like on the AP test, like the multiple choice, the answers look like that. So like they even leave them like that. Okay, we ready for another one? I'm thinking it's time to throw some trig in there. Okay, we're gonna do y equals 7 to the tangent of x. So the power still has a variable in it, still has that x. So that means we need to put a natural log in. I can then bring my tangent of x down times the natural log of 7. Okay, now this next part I'm going to tell you. Like, you know, last year when you did natural logs and you had your calculator, if you typed in your calculator natural log of 7, it would give you like a weird decimal. Whatever it is, it's a weird decimal. So this technically is a constant. Even though it's like a crazy decimal, it's a constant. Kind of just like e is a constant and pi is a constant. Okay, so let me take you back to like a couple months ago. If I asked you to derive this, what would you do with the 7? What do you mean by nothing? Kind of. It stays. It's a constant. Or, okay, I'll take it back even further. What does that 7 go away, or you kind of incorporate it into multiplying by the 2? Okay, so back to 7 tangent x. We would keep the 7, derive tangent of x. So now we have to remember, what's the derivative of tangent of x? Secant squared. Okay, so now with that, this is technically, I'm going to write it another way so it's easier to see. I can flip the order. This is technically a constant, even though it's weird. So I can have the constant tag along times the derivative of tangent. What that does is it gets us out of a product rule. And then this side is just 1 over y dy dx. So if you see natural log of a constant, that whole thing represents a constant. And then we just have to take this side and multiply it by the y. So that'll be dy dx equals the natural log of 7 times secant squared x, all times 7 to the tangent of x. So it saves us a little bit of work, and anytime we can save work, we have less room for error when we see that. Okay, next one I want to do, let's try this one. Yeah. Okay, so we have variable in the power, which means we have to put a natural log in. We'll bring that power to the front. Okay, now again, this is a constant, natural log of 2. So I can just carry that along times the derivative of this. And the derivative of that is 2x. And then we'll have on this side 1 over y dy dx. And then multiply each side by y. Okay, let's do another trig one. Okay, let's try. The cosine of x to the x plus 1 power. So natural log in there. The whole x plus 1 comes down to the front. Then we have natural log of the cosine of x. So these two things are being multiplied together, and we have to go back to a product rule now because neither one of those are just a constant. So now we've got everything out of the powers we can derive. 1 over y dy dx. And then product rule says first times the derivative of the second. So for natural log, it's 1 over u times the derivative of u, which is going to be negative sign. So first times the derivative of the second plus second times the derivative of the first, which is just a 1. And then I'm going to kind of squish things together and multiply by y all at once. How are we feeling? Okay? All right, let me find another one for us to do. Okay, next one. Oops. So next one will be this. Y equals the secant of x to the natural log of x. Okay, this is gonna get complicated fast. So do we still need to put a natural log in? Is there still a variable in the power? Yes. So we have to put a natural log in there, which means we bring down the power and there is just a whole bunch of natural log stuff going on there. What rule do we have to do on the right-hand side? Product. So 1 over y dy dx. Okay, on the right, it's this times this. So the first times the derivative of the second, 1 over u times the derivative of u. What's the derivative of secant? Secant tangent. So first times the derivative of the second plus second times the derivative of the first. And the derivative of the natural log of x is 1 over x. Do you remember what we did with something like this yesterday? Get rid of those secants right there. So now I'm going to scrunch it together and multiply by y. So dy dx equals the natural log of x times the tangent of x plus the natural log of the secant of x divided by x, all times that beginning equation. Whew. No numbers. If you showed this to pre-calc right now, I would have no class next year. Don't tell them. Make them suffer next year. What? Oh, what'd you say about pre-calc? Oh, oh. Even like after a day like today, no numbers. All right, I'm gonna have to make. I do. Yeah, we can like take our time on sections. Yeah, yeah, we can take our time more. All right, I'm thinking we should do one more problem. I gotta make it a good one though. Oh, I got it. I got it. Got it. What? What are you calling? The problem. Yeah, okay, here it is. It is. And do we still have to put another one in there? Yes. Okay, we're going to be very organized with this. So we'll be very careful with our parentheses. So we're going to bring this natural log down. Times this bottom stuff already. Woo! Okay, make sure we're good there. Okay, on the right-hand side, what's the major rule? Product. So these are the two parts. Okay, left is like normal. 1 over y dy dx. Okay, we're going to take this slow. First times the derivative of the second. So this right here, all of this is our u. So 1 over u times the derivative of u. What's the derivative of u? 1 over x. So first times the derivative of the second plus second times the derivative of the first. This stuff cancels. So then we'll have, I squish and multiply by y. We'll have 1 over x plus the natural log of the natural log of x divided by x. And then times it by our original. The natural log of x to the natural log of x power. That, oh, and since this... I know. Wait till you get to college math. You guys are going to have so much fun. So much fun. I know. Since it's our last problem, we got to give it some pizzazz. Kylie would only want it. I know. I don't know if she'll watch the video. I know. Okay, we're in a good shape now. I feel like we're good.